Okay, so let's come together and just kind of touch base. First of all, we've already established this is 1 hour and 40 minutes. That is a big ask to be doing math, 1 hour, 40 minutes straight. That is what you signed up for. I'm not here to make it any easier for you. I'm just here to be straight with you. You signed up for a course that meets twice a week. If you took a course meeting 3 times a week, it would be 1 hour and 10 minutes, which might feel more humane to some of us, but it's the same number of minutes in only 2 meetings instead of 3. So we're working on math for 1 hour and 40 minutes every Tuesday, Thursday. Just to kind of give us a sense of the flow of the course, we just finished what I call lesson number 1, and it had the demo where we were kind of working together. It had the activities, which is how you spent the bulk of this class. Some folks really sped through the activities and got to the even more practice. Do not feel badly if you did not get to the even more practice. But if you did not finish the activities, I'm hoping between now and when we next meet, you do finish the activities. Again, the even more practice is optional. I have no expectation that you'll finish that or even start that, but I do expect you'll finish the activities. Let's take a look at this homework packet. You don't need to take it out. But again, we just finished lesson number 1, and so the homework assignment is right here labeled 1. And so the current active homework assignment that is due next time is here, sections 1.3 and 1.4. These problems, or in the 7th edition, slightly different problems, okay? So this is how we're reading the homework packet.
So is it like 5?
Is it what? 5, and then 47, and then 49. Okay. All right. So let's take a look. Yes, question. Great question. So again, you signed up for a Tuesday, Thursday class, and between Thursday and Tuesday is 5 whole days. But between Tuesday and Thursday is only 2 days, and it is not symmetric, and there's nothing I can do about that. Here is the idea. Every lesson has a homework assignment. Roughly, we're going to be doing a lesson and a half every class period. And so we finished lesson 1, and we're actually about to start lesson 2 right now. We're not going to finish lesson 2, and there isn't going to be a lesson 2 homework assignment due next class. So it's going to be 1 homework assignment today. But next class, on Tuesday, we're going to finish lesson 2 and do all of lesson 3, which is 2 homework assignments for you. And so some days there are going to be 1 homework assignment, and some days there are going to be 2. And I did not try to control like whether it happens on a Tuesday or a Thursday. It is what it is. But I always give you guys a 1 class grace period on homework. So you always have a full week to do the homework that was just assigned, okay? But hopefully you'll be able to kind of space things out because it is not spaced out evenly according to the Tuesday, Thursday calendar, right? Good question. Okay. So just in terms of this homework assignment, what's going to happen is you're going to write your answers to all of those homework problems, not just answers, but the work to I want to see algebra. It's an algebra class. And before class on Tuesday, I'm going to walk around and just do a very quick spot check to get full credit for the homework. You don't need to get them all right. You need to have made a solid effort on all the problems and done algebra to justify, okay? That's the goal. So I will do that right before class for anybody that I have time to do before class and right after class if I don't get to you before class, all right? So before class every day, I'm just gonna walk around and check homework stuff. All right, so couple of other bookkeeping things before we move on. First of all, this is the math flow chart, and I will just tell you that you are right now here in Math 096. The fact that this course has a 0 in the front of the course number means it does not count for the math credit on any degree that GCC offers. I'm not saying it's a bad course. I'm just telling you it does not count to fulfill the math requirement of any of our degrees. And in particular, I think we probably have a lot of liberal arts general majors in this room. This does not fill the math requirement. Yes? Yeah, but what I'm talking about is, yeah, let's talk separately, Kate. But what I'm talking about is the liberal arts math requirement. It says any math course that does not start with a 0. But in particular, on the same level in this flowchart as this course called Math 117, which is called Mathematical Problem Solving, by virtue of being eligible to take this course, all or almost all of you are also eligible to take 117 right now this semester. And I will say that 117 does satisfy the liberal arts math requirement. Whereas if you stay on the path that you're on, most of you are either going to go to Math 107, which is college algebra, or Math 114, which is a statistics class. Either of those fulfills the math requirement. But if your goal is simply to fulfill the math requirement, then perhaps 117 is a better bet because it's only one course this semester instead of this course and then one more next semester. Whether or not you take the green path or the yellow path really depends on your major and potential future career, but it's something that we should talk about like right after class if you're interested. If you're not sure whether this is the right place for you, I just want to be clear, you could fulfill the math requirement this semester instead of next semester. Okay. All right, I think that's good. Let's take a look at what I'm going to call the syllabus calendar. I think this is the last page of the syllabus. Go ahead and open it up right now. Just take a look at the very back of the syllabus. And you will find this crazy looking grid. Okay, everybody up here. So this grid is asking a lot. Let's just see if we can kind of get a handle on what's going on with this first look. On the left-hand column, you can see today's date, January 26th. Lessons covered. All of lesson 1, and then that S after lesson 2 means we are going to start lesson 2. We're starting lesson 2. And then when we come back on Tuesday, you can see it right here, January 31st, we are going to finish lesson 2 and do all of lesson 3. So these first two columns kind of behave separately from the rest of this spreadsheet, okay? That tells you what we're doing, but the rest of the spreadsheet gives you a little bit more detail. So for example, right here, this is also lesson number 1. That is the one that we just finished. It covers section 1.3 and 1.4 in your textbook. There's some words describing the material. There's a homework due date. Default is the homework is due the class after we finish the material. However, I recognize that some of us don't have a book, and so I'm going to give you guys a little bit more time just in the beginning of the semester to make sure that people have their book. Me saying February 2nd is not my way of saying don't look at this until February 1st. If you have the book, do the homework tonight, okay? Don't wait. But we got a little bit of a grace period here in the beginning. Okay, so what we are going to do right now is start lesson number 2. Which is this guy right here. And lesson number 2 starts a few pages after wherever we ended up. So let's take a look at page 9. Everybody going to page 9 in the big packet. Okay, daily summary. In this lesson, we tackle our first word problems and see a powerful technique for starting word problems. Pick a random number and figure out how to set up your expressions or equations. So first time we'll be talking about word problems. I promise you it will not be the last time. Remember I mentioned something called My Math Lab, and that's the acronym for My Math Lab, and I said you're going to see references to it and you're going to ignore them. So all of this stuff right here about My Math Lab you can cross off. Does not apply anymore. Okay, so we're going to jump in with number 2 here. It says this is a calculator active problem. What that means is that this is one of the rare problems in the class packet where you are allowed to use your calculator. What that also means is that some of us who are using calculators during the activity here, we're not quite doing things the way that I wanted us to do them. So in general, this is not a calculator intensive course. When I want you to use a calculator, you're going to see this phrase, calculator active, okay? Some of the quizzes, some of the tests will be calculator inactive. So using a calculator on problems in class might make them easier in class, but will not necessarily prepare you to do well on tests and quizzes where you won't have that device in your hand. Okay, so here's the problem. The price of a 7-day Alaskan cruise, normally $2,752 per person, is reduced by $1.75 per person for large groups traveling together. How large a group is needed for the price to be $2,500 per person? And there's more to it here, but let's just make sure we understand what's going on with this problem. Normally the ticket is $2,752, but if we got a bunch of us going together, we each pay less. We pay $1.75 less for every person that we have in our group. So for example, if there's 2 people in our group, then we would pay how much less? $2.75 discounts is how much? It's $3.50, right? $3.50. So if we got two people going together, we would get to subtract $3.50 from that original price. And the more people we have, the more discounts we get to take off. And would you buy that eventually we could get this price to drop from $27.52 to something around $2,500? Apparently it's going to work out perfectly, but with enough people, right? We can keep dropping this thing down. The goal is to figure out how many people to drop it to $2,500. Now, some lucky people in this room might already understand, oh, if I let X equal this, then this is the expression with X in it that represents the discounted ticket price. That's fantastic if you were one of those lucky people. But for the rest of us who cannot sort of naturally make that big leap between all of those words and the expression with X in it, we're just going to try plugging in some numbers. So for example, the first column here, number of people traveling in large groups. I'm just making up a number, 10 people. So if there are 10 people, then we get 10 discounts of $1.75 each. So how would I figure out the total discount? What am I doing with 10 and $1.75? Multiplying them. Okay, that's easy. 10 times $1.75 is $17.50. Is that the new ticket price? No, what is that? That's the discount, right? We get to take $17.50 off of the original price. Remember, the original price was $2,752, so we subtract $17.50 and we get $2,734.50. That's the new price when we have 10 people in the group. Price per person, $27.34.50. There? Okay, so it's pretty straightforward to do it when there's 10 people. Let's try it when there's 50 people. We're going to play the same game. I've got 50 people and I've got a discount of $1.75 each. What am I doing with those numbers? So we're multiplying. So again, one of the few places where I say go ahead and use your calculator. So if you have it out, great. If you don't have it out, don't worry about it. We just need one person to help us out here. Okay, $87.50. What does that represent? That's the discount. But I want to know what the final price is. So what am I doing with this $87.50?
You minus it from $27.52.
That's it, right? We take the original $27.52 and we subtract off the discount. Yeah. All right, what do we get here? You guys are making me work up here. Can somebody help me out? 65. Thank you. All right, hold on, you go.
Wait, isn't it 26.64?
64?
Yeah.
2664.50. Okay, so that's the specific examples, right? It's pretty straightforward to plug in the numbers, right? Okay, so quick detour before we fill in the bottom row here. It says a quantity. We're going to define quantity in unit right now. And if you took Math 095 here, there's a good chance you spent a bunch of time thinking about quantities and units and making sure that every time you introduced a variable, you included a quantity word and a unit word in your definition for that variable. So here we go. A quantity is anything that can be counted or measured. No more, no less. A quantity is anything that can be counted or measured. So for example, I can measure the length of one wall in this room. I can measure the weight of one of these tables. I can measure the area of my hand. I can count the number of blue cars in the parking lot. I could find the volume of my water bottle. And I can measure time passing, right? Seems to have passed maybe a little bit slower than normal in these last 90 minutes. That's a joke. It's funny. Yeah, okay. All of those things are quantity words. A unit is a fundamental amount of some quantity. So all of these things that I just said I could measure, well, it doesn't make sense if I say the length of this room is 12. Why does that have no meaning? I need 12 what, right? Is it 12 feet? Is it 12 meters? Is it 12 yards? Is it 12 light years? What 12 what, right? So the what, the thing that is this fundamental amount, are called units. So units, feet is a unit, meters is a unit, light years is a unit. So here are some typical units. There are many more: inches, pounds, square meters, cars, that was how many cars in the parking lot, cubic feet, and hours for time passing. If you have a quantity word and a unit word, and you're not sure which is which, put a random number in front of each word. The word that makes sense with the number in the front of it is a unit. So for example, if my choice is length and inches, I'm going to put a 12 in front of both of them. 12 length, 12 inches. One of them makes sense. That one is the unit word, okay? So all of these guys here are unit words. All right. So on the next page, number 4. It says, let's use a quantity word and a unit word to carefully define the variable for that cruise problem. The problem asked us specifically, it said, how many people need to go on this cruise in order to make the price $2,500 per person? So the variable is the number of people going on the trip. And almost every word problem you face in this class, the definition for the variable is going to be embedded in the question. You just have to read it. If you go back, the question said, how many people? Great. That's what we need to let x equal, the number of people. But there are lots of ways to define x that are kind of wishy-washy, and that's not so great. So if you say let x equal people, I'm going to say, well, what are you talking about for the people? Are you talking about how tall they are? Are you talking about how much weight they have? You're talking about what they had for lunch? The people have a lot of characteristics. You need to be very clear when you define your variable. So number of people going on the trip, okay? Number is the quantity word. Okay, if we go back to our table, what we've just decided is that we're going to try to make this leap between the easy numerical calculations with 10 and 50 people and the much more challenging abstract concept of x, where x is the number of people. We've already done the calculations a couple of times with specific numbers, so let's see if we can follow the pattern that we established up here. We had 10 people, we multiplied 10 by $1.75. We had 50 people, we multiplied 50 by $1.75. If we have x people, we're going to multiply x by $1.75. So I'm going to put the x in the front. Actually, kind of looks a little bit weird to me to not put $1.75x, but I'm really just trying to naively follow that pattern we established. And then what did we do once we calculated the discount, like $87.50, subtracted from $27.52, and that was consistent, right? It was $27.52 minus whatever we just got. $27.52 minus what we got. $27.52 minus what we got. That is our pattern. $27.52 minus what we got. So I'm going to put that in the order that I want to put it in now, which is $1.75x. That's it. That's the last piece of this, right? We want the discounted price to be $2,500 per person. This expression represents the discounted price, so that's our equation. 27.52 minus 1.75x equals the $2,500 per person. Okay, so that is essentially the end of the demo. We're going to pick up here on Tuesday, just jumping in and solving word problems. I will remind you Tuesday morning of the highlights of this problem, okay? All right, have a wonderful rest of your first day.